Hello guys, this video is about domain of radical functions. Okay, domain of radical functions. Now, um, I know I've covered equations, radical equations. I believe I've covered addition and subtraction of radical expressions. I've covered, some stuff about radical expressions. So now, domain of radical functions. One thing to know, and I don't remember whether I explained that from my other video, but one thing you have to know is that for radical equations, if it's written like this, like the nth root of a, remember this is the index right here, index, and this is the radicand. This is the radicand. So if the radicand, if n is let me write it here, if n is even, therefore the radicand must be non-negative. Okay, the radicand must be non-negative because anytime n is even. And what you can, if you have a calculator now, you may try to get the square root, in which case n will be even because it's a 2, the square root, or even the fourth root of -1, for example. Okay, it will give you an error. Why? Because there's no way you can multiply a number by itself 4 times, whatever the number, by itself 4 times. Let's say if the number was a, okay, I know a is a letter, but I'm just saying if a replaces a number, a variable, okay? So now if a times a times a times a, you can't try to think of a number as a to get -1. Now, I know some of you would say, hey, if I multiply 1 by itself, I'll get 1. But how about -1 by itself? 4 times, okay? This is +1, okay? It's positive. So it's not -1, it's +1, okay? -1 times -1. So if you use your calculator, it will give you an error because there's no way you can take some real numbers and multiply them, integers, multiply them real numbers to get -1. Never. It won't happen. Okay? So you would have to get an imaginary number. Okay? But we're working on the real number set. So no number can give you the -1. Okay? That's why the radicand must be non-negative if n is even, the index I'm saying. Now, if n is odd, if the index is odd, you're free, right? Radicand can be any integer, right? Any integer. Could be either negative or positive. So, for example, you may do the cube root of -1. That's -1 because -1 times -1 times -1 3 times, because it's a cube root, will give you -1. So this one's good, right? Now, this is very important because of what I'm explaining here. What am I trying to say? Okay, well, what I'm trying to say is, remember the definition of domain from my previous video where I covered the domain of rational functions, right? So for the domain, will be a set of all the input values for which the function works, for which there's an output value. So what I mean is, if you plug the x value into the function, you will get a y value, f of x, right? So in this case here, if it's If it's a negative number, for example, if I had the square root of x, if x is -1, then there won't be a y value, because then y will be square root of -1, which is not a real number. Not a real number, right? So that's what I'm saying. So in order for you to get a y value with an x value, it has to be either 0 or positive. Therefore, this would be defined from 0 to positive infinity, okay? All right? Okay, so enough. I'm explaining, but let me show you how to solve these problems. It will make sense to you. Okay, so knowing everything I just said here, then keeping it simple, we could just say this. First thing to do, if I'm trying to get the domain of radical functions, the first thing to do is to check the index. In this case here, if it's even, I know what I have here must be positive, not negative, okay? If it's odd, I know it could be anything, right? Okay, let's see, let me show you what I mean. So in this case here, I see that the index n equals to 4. Okay, so if the index is 4, we know this is even, right? 4 is even. Since it's even, I know what I have as the radicand must be, so I'm putting everything I explained into mathematical terms now. So the radicand must be non-negative. That's what I said, right? Well, what does that mean? The radicand, what is it? It's t minus 2. Must be non-negative means what? It must be greater than 0 or equal to 0. Just non-negative, so greater than or equal to 0. Okay? Then what value of t would give me such things? Well, I just need to solve this. Add 2 to both sides. Then you have t greater than or equal to 2, okay? Then if you don't remember how to just jump to the interval notation or set builder notation, you can just do your number line and putting 2 here. Now greater than 2, so I know I'm gonna be right here on the right to positive infinity, right? Therefore the domain here will be all x, all t values from 2 to positive infinity. Okay, that's it. From 2 to positive infinity. Again, keeping it simple. If this is even, okay, the index, if it's even, take this, the radicand, set it greater than or equal to 0. Always what you have to do. Always. If the index is even, take the radicand. By radicand, I mean what's under the radical. Take it, set it greater than or equal to 0, because it has to be positive or 0, okay? Then you solve. That's all. If it's odd, is there any restriction, as in this case here? N is odd, right? Then if it's odd, what did we say? The radicand can be anything. It can be positive, it can be negative, so it can be anything. It can be 0. So what's the problem? What are the restrictions? There's no restriction. Why? Because it's odd. And if it's odd, I can put anything I want for A here. It could be negative, could be positive, doesn't matter. It will still work. There will still be a value of y for any value of the input, which is A in this case, okay? So, therefore, the domain will be all real numbers. Okay? In other words, from negative infinity to positive infinity, because no restriction, you're taking all values, okay? So again, remember, if I'm solving any problems and I realize that the index is even, then I need to set the radicand greater than or equal to 0. Always like this, okay? Always greater than or equal to 0. Now I'm talking about this, by the way. If I see an odd index, then I know automatically it's all real numbers because there are no restrictions, okay? That's all I had for you. Domain of radical functions. Thank you.